Hello, this is Mr. Kyle Munyon here bringing you Activity 3-1 of the Axiomatic System of Geometry. We'll be focusing on geometric definitions and two-column proofs. So starting on 3-1, we have a little paragraph about the axiomatic system. Please pause for a moment, read down that first paragraph till we get to here. Once you're done reading, you'll notice that we have a statement about a fountain, a rundle that is bari wavy of 6 argent and azure. Doesn't make any sense because obviously most of these words, you're probably like, I don't know what any of these words here mean. So it's kind of pointless to define fountain with any of these words here that we don't know what they mean. Whereas a guide, a belt that is worn over the right shoulder and used to support, I know what a belt is, I know what worn means, your right shoulder, support, shield, I know what all of those words mean. So when I ask which of the two definitions is easier to understand, I would say the second one, because it's defined with words that we already understand that we have a definition meaning for. So the second one would definitely be easier to understand because it's defined with words that we already know. So in geometry, we use what's called an axiomatic system. It's called an axiomatic system because we start with a few things that are just given to us. We need to know what these words mean so that we can use them to define other words. So we have a point, line, and plane. Hopefully from your previous geometry courses, you have an idea of what those mean. A point represents a specific place. A line is an infinite number of points connected together, continues forever in each direction, and a plane is an infinite number of lines together. We kind of represent them what looks to be kind of like a parallelogram shape. You can think of your wall or the floor or a sheet of paper as a plane. Technically, a plane does go on forever, though, unless you define the edges of it. So knowing what a point, line, and plane are, we should be able to define some other things in geometry. So some of the other basic terms that we can talk about in geometry would be a ray, collinear points, coplanar points, and some on the next page as well. So what is a ray if we are using some of the undefined terms to define it? So a ray looks like this, and we can think of that as having an endpoint, so that's one of our undefined terms, and being part of a line. So a line continues forever in each direction, but a ray has one endpoint and continues forever in one direction, so it's part of a line containing an endpoint and continuing forever in one direction. So if we wanted to define that using the undefined terms, we could say that a ray is part of a line. Containing an endpoint and continuing forever in one direction. So notice the example I drew here at the end is ray AB, starts at point A, continues through B. Collinear points, how could we define that using undefined terms? Those would be points contained on the same line. So just like co-workers work at the same place, collinear points would be points that are contained on the same line. So here, for example, notice I have 3 points that I've identified on this line. They would all be considered collinear. So to define this using the undefined terms, we could call them collinear points, or points that are contained on the same line. And coplanar points, same concept, except for instead of being on a line, we could think of them as being on a plane. So let's say we have plane R and a few different points identified somewhere on that plane, we could say they're on the same plane, so they would be coplanar. Notice these 3 points are not collinear because there's not one line you could draw to go through all 3 of them, but they are coplanar. So points contained on the same plane would be the definition we could use to identify using our undefined terms. So points that lay on the same plane. So that's the biggest difference between collinear points and coplanar points. Collinear is on the same line, coplanar is on the same plane. All right, we could also continue on this definition with some other new vocabulary words. Actually, these probably aren't new. You should know what complementary and supplementary angles are already from a previous geometry course. Hopefully you remember that complementary angles are angles that are created or 2 angles that add up to 90 degrees. So if we know what an angle is, it's formed by 2 rays with a common endpoint. So here's a ray, creates an angle right there. Complementary angles are any 2 angles that have a sum of 90 degrees. That's kind of ugly. And supplementary, maybe that refreshed your memory for supplementary, should be 2 angles that have a sum of 180 degrees. All right, and sum means add up to. So an example could be like a 40-degree angle and a 50-degree angle for complementary. For 180, you could have one angle that's 100 and one angle that's 80. Those would be considered supplementary. All right, the process for deductive reasoning or deduction must have a starting point. A conclusion based on deduction cannot be made unless there is an established assertion to work blah blah blah. Basically, we need to go in order to be able to use deductive reasoning. We can go step by step. We can't skip any steps without having a reason for it. So using one operation or property per step, so one at a time, show how to solve this equation and name each property. Conveniently on this page, the PDF, we do have all the properties listed. I don't know if these properties are listed on the online version, so obviously you're welcome to take a look over these. Most of the addition, subtraction ones are common sense, but you may need a little quick refresher over some of these other properties down here as well. So let's solve this one and go one step at a time. Once we've solved it, then we'll go back and see if we can't name the reason why we could do that step. So 4x plus 9 equals 18 minus 1/2 x. First step is simplify, combine like terms on each side of the equation. Nothing to do here on the left side, nothing to do on the right side. Second step is isolate your variable. So it looks like I have a negative 1/2 x and a 4x. I can't solve for both of those, so I need to cancel one out. I am going to add 1/2 x to both sides. All right, now that I've isolated my variable, I can start solving for x using inverse operations. So I need to get rid of the 9 and the 4.5 that are happening to x. Order of operations, undoing them tells me I need to get rid of the 9 first. So I could subtract 9 from both sides. And now I can undo multiplying by 4.5. I can divide both sides by 4.5. And I end up with this answer. So what is the step that I did each time, and see if that's a property over here. So the first step, I was able to add something to both sides of the equation. That is the addition property of equality. So we added something to both sides. That's the addition property of equality. I'm going to save a little bit of time here for each one of these. Looks like we use the subtraction property of equality. To save time, I'm not going to put a property of equality on every single one of these. And then we divided something from both sides, so division property of equality. And after that, we were done. So this is justifying each one of our steps. We know that these are properties of equalities. Hopefully, when you first learned algebra, you learned that these were some of the properties that you could do to help you solve equations. All right, so here's an example of a two-column proof. It's just a little bit more organized. They have a statement, they have a reason. A couple things I want you to notice on this one is the very first part of your statement. That is what's given to you. So that's going to be real easy. Listing what's given and having a reason, that's given. The last part is what you're trying to prove. So literally your last statement is going to be what you're trying to prove, and eventually you'll be able to come up to a reason that you did that step. They didn't actually put what they did to each side right here on the left and right side of each equation on this example, and you wouldn't put that. You would just put the reason off to the right side of why you were able to do that step. So first thing I notice right here is, looks to me like they added 1 to both sides right here and here. They added 1 to get rid of it, and they added 1 here to get to 12, so they used addition property of equality. Next thing, they distributed here, so the 3 went to the x and the 2, so you get a 3x and a 6. You have the distributive property of equality. From there, they isolate their variable, subtracted 3x from this side to cancel it out, subtracted, so subtraction property of equality. And then they solved, they got rid of the 12 and the 2, so subtraction property again to subtract off the 12, division property to cancel out multiplying by 2, they did that one. Last one, I don't know that you need to do this one because negative 3 equals x is the same as x equals negative 3, but they went ahead and put symmetric property of equality. If a equals b, then b equals a, same thing. Ultimately, they just did it because that is what you were trying to prove it with it on the left side. I wouldn't say that you needed to do that one though. All right, let's try one. I would like you guys to just look through this one. Hopefully you see what steps they're doing 1 through 7. Pause the video here for just a moment and see if you can come up with the reasons. You should definitely be able to do anytime there's addition, subtraction, multiplication, or division. And before you start the video, and if you get stuck somewhere, just go back and look at this example or the notes up here on the different types of them, because it's probably going to be distributive, reflexive, symmetric, transitive, or substitution. Probably one of these, these are the only reasons you're going to use up there. So check this out before you press play again. Go ahead and pause now. All right, now that you've given it a chance, let's see how far you got, if you got stuck, or if you got the right answer. Great job. So first one, this is the given. The first thing we put here is given. From here, it looks like they multiplied both sides by 10. So this whole thing got multiplied by 10. This whole thing got multiplied by 10. So multiplication property of equality. All right. From here, there was a 10 and a 2 and a 10 and a 5 that got replaced with something else. The 10 and the 2, that 10 divided by 2 is 5, and they replaced it, the 10 and the 2 divided by 5. And here, the 10 and the 5, 10 divided by 5 is 2, they replaced that. They didn't do the same thing on both sides. All they did was simplify or substituted a 5 in place of 10 over 2. Or they substituted here, they substituted a 2 in place. So this is the substitution property of equality. From there, it looks like they just distributed the 5 to the x minus 3, and they distributed there, so distributive property. And from here, now that they simplified the left and right side, looks like they subtracted 2x from both sides, canceled out the 2x, minus 2x here, so subtraction, property of equality. Added 15 to both sides, added 15 here, canceled out, added 15 here to get 27. So addition, property of equality. Whoops, don't know what happened there. And then last one is division, property of equality, divided both sides by 3. All right, so if you got all of those reasons correct, great job. This one wasn't too bad. This one might have tripped a few people up, but the rest of them pretty clear. Even distributive, I think most of you guys probably could have gotten just from past experience. People tend to only get tripped up on the substitution one because you don't really have to put your reasons when you're solving most of the time. All right, so let's try one here. Let's do our own 2-column proof. Let's set this up with statements and reasons and see what you guys can do on this one. So statements and reasons. What's the very first thing that you always start with, and what's the last thing you're going to end up with? Put your given here. So this is going to be 4x plus 9 equals 18 minus 1/2 x. And when you're done, the very last statement should be x equals whatever you get. And obviously you should have all your reasons listed. So pause the video here, see what you guys can come up with. Just a moment, we'll go over it. Okay, so now that you've had a moment to try this one, let's see how far we can get. I'm going to draw this a little bit cleaner just so we have enough room to work here. So let's do statements and reasons. Did we already do this one? Oh, I guess we didn't put the reasons on there why we did it, but yeah, we did. All right, so both sides are already simplified, so I can isolate my variable. I'm going to add 1/2 x to both sides. From here, you can subtract 9 from both sides, so we get the 9 here cancels out. 18 minus 9 is 9, and divide by 4.5 on both sides. All right, so let's just put our reasons, and we should be good. I guess if you wanted to number them, you could. So we always start off with given information. That's what we were given. First step was subtraction property of equality. I subtracted 1/2 x from both sides, so subtraction property of equality. Next step was I subtracted 9 from both sides. And last step was a division property of equality. So that was actually pretty easy. So then our prove statement was we were trying to prove x equals 2. I guess since we were supposed to list what we were trying to prove on that one. All right, hopefully you guys are feeling all right about these. So you should be ready to try some more on your own. So I guess pause here. You can try questions 5, 6, and 7. Obviously, if you want to check your answers, you can start the video again once you're done. Please do not just look at the answers and assume you know what you're doing. Pause for a moment, and we'll go over them in just a moment. All right, now that you are done trying these, explain why we use undefined terms or why they're necessary in geometry. Well, just like anything, we need a starting point. We need to know the definitions of some things. So we give you a few terms to start with called the undefined terms, so that we can use those to define other geometric terms. So undefined terms are a starting point for defining other geometric terms for number 5. What is the relationship between a conjecture, a theorem, and a 2-column proof? So a conjecture is a statement that you believe to be true. A theorem is accepted as true, and a 2-column proof is basically proving something using deductive reasoning. All right, for number 7, hopefully you looked at that and realized that the answer was wrong. In addition to the wrong proof statement, what did he do wrong and rewrite this proof? Actually, the majority of it's pretty good until the very last step. So he did start with the given information. He did distribute there on that side correctly, so he did use the distributive property. He did add 6x to both sides to cancel out that negative 6x, so addition property. He did all this correctly. He then did subtract 15 from both sides, so subtraction. But how do you get rid of multiplying by 9? You're supposed to divide by 9. So the only thing that should have changed was he should have divided both sides by 9 and used the division property of equality. So if you divide by 9, you get 1. You divide by 9, you get negative 1 on each side. So 1x equals negative 1, and it should have been the division property on that one. I'm assuming most of you guys probably did okay on that one. Hopefully it didn't trip you up. All right, same thing for lesson practice. Please take a moment to try these 5 questions. Pause now. Once you're done, we'll go over, start the video again, and I'll go over each of these. All right, hopefully you've taken the time to try and answer each of these. Identify the property that justifies the statement 4x minus 3 equals 7. Then 4x equals 10. Looks like they added 3 to both sides, so the addition property of equality. Obviously, I'm abbreviating all of these properties of equalities just because they take forever to write and my handwriting is ugly. Complete the proof statement and write a 2-column proof for this equation. Okay. Seems pretty reasonable. I'll go ahead and do that over here. We've got some room. Where are we at? X minus 2 equals 3 parentheses x minus 4. So x minus 2 equals 3x minus 4. Parentheses. All right, so let's do our statements and our reasons. First statement is x minus 2 equals 3, and that was given. All right, so first thing I could do would be simplify both sides. I could distribute this 3 to both of those. So x minus 2 equals 3x minus 12, and that is the distributive property of equality. From here, both sides are simplified. I can isolate my variable, so I can cancel out this x by subtracting x and subtracting x. So negative 2 equals 2x minus 12. So I subtract it from both sides. That's the subtraction property of equality. All right, from here I can now start solving for x. I could add 12 and then divide by 2. So add 12 to both sides. You add 12 here, cancels out. Add 12 here, negative 2 plus 12 is positive 10. So I added, so that's the addition property of equality. And last step is divide both sides by 2. And you get x equals 5, so that is the division property of equality. And if you wanted to do the last step of getting x equals, you don't have to because it's not what we are trying to prove. You could just say what we're trying to prove is 5 equals x. Or you could do the symmetric property of equality and switch it around and say x equals 5 if you wanted to do that. So if you wanted to say x equals 5, you could use the symmetric property of equality. All right, so then obviously our proof is here, and then what we're trying to prove is x equals 5 on that one. All right, for number 10, explain why a line segment is considered a defined term. So in our axiomatic system in geometry, the only undefined terms are point, line, and plane. So a line segment is a defined term because it can be defined using other things we've already defined. So a line segment is part of a line. So a line itself is an undefined term, but a line segment is part of a line. So just a reminder, a line continues on forever in both directions. A line segment is only part of a line in between two end points. So we define it as part of a line in between two points that are on that line and all of the space in between. So the top one here is a line and the bottom one is a line segment because it's defined as part of a line. We can use the undefined terms to define it basically. Number 11, complete and prove statement in 2-column proof for this equation. Prove, okay, I'm going to go ahead and do that one on the same spot over here. Just erase this one. And we should have some room to do that one. 2n minus 21 equals n over 4. 2n minus 21 equals n over 4. This is going to be our given, and solve it and basically justify your reasons on each step. So statements and reasons. That is given. Solving this one, looks like both sides are already simplified. You could do this in a couple of different ways. If you were to, I guess it doesn't really matter. So some people don't like fractions. So the very first thing they would do would multiply by 4 and you get rid of your fractions. You could do that, or you could try to isolate your variable right now. If you want to subtract 1/4 n from both sides, you could do that. To make it easier, since I know most of you guys probably hate fractions, I'm going to multiply both sides by 4 right now and make it a real easy property as well. So multiply both sides by 4. I guess I ran out of room there. All right, so now that we have this, we could, I guess we can only do one of these at a time. I'm going to substitute a 1 right here for 4 over 4. So I'm going to leave the left side the same. So 4 divided by 4 is 1, so I end up with 1n. From there you could distribute, so I'm going to use the distributive property, 8n minus 84 equals n. That's the distributive property. Now I can isolate my variable and subtract n from both sides. Whoops. Did one too many steps there. So that subtracted n from both sides. That was the subtraction property of equality. I could add 84 to both sides. Addition property of equality. And divide both sides by 7. Looks like we get 12. And dividing both sides by 7, so division property of equality. All right, hopefully that's what we're trying to prove. So we're trying to prove n equals 12 on that one, and I put all my statements and reasons on there. Number 12, suppose that you were given a equals b plus 2 and b plus 2 equals 5. What can you prove by using these statements and the transitive property? Looks like right there, you could prove that a equals 5 using the transitive property. If they both equal b plus 2, then they have to be equal to each other using the transitive property. All right, well that concludes our lesson 3-1. Don't forget to make sure that you, when you're done with all 3 lessons, that you do the homework practice for activity 3 at the end.